So we're looking at vectors past paper questions. When you go through all the information in the question, you always make sure, is there anything else I want to add to the diagram? So in this case, we have this distance OP that's 10, and we have BR that's also 10, so 8 plus 2. A reminder that's there. M is a midpoint, so AM and MT are equal in length. They ask us, for the case where A equals 2, find the unit vector in the direction of PM. So A is going to equal 2 from P to M. When we've got a diagram and we're looking at something like this, it really is just a case of walking around the diagram. So if we start at P, how are we going to get to M, our ending point? And you've got to walk like an ant. Okay, so from P down to O. P to O is down K, so minus, and it's a whole 10 of it. So PM equals minus 10K. I'm going to go across the bottom here to get to A. So my little a is 2, so this is in the I direction plus 2I. Remembering to underline as we go. Now we're on this face of ABRQ, and we've got to get halfway along AT to get to M. Okay, so if we think of this as a new face, which is 8 by 6, okay, then we're going to be going, so we've got 8 by 6. We're going halfway across here. So halfway along and halfway up. So halfway along would take us plus 3J. And halfway up would take us plus 4K. So what we've ended up with is a mixture of IJs and Ks. Okay, we have like terms, components in K, and we don't have it in IJK format. So our next step is very simply to simplify this. So we then know that PM equals first I, 2I, then J plus 3J, then K, minus 10 plus 4 minus 6K. So now we've got the vector in the direction from P to M, but they asked us for the unit vector. In order to get a unit vector, we have to multiply by 1 over the magnitude. So now we need magnitude of PM. Equals square root. So it will be 2 squared plus 3 squared plus minus 6 squared. Being very careful with all those negative signs because you don't want them to trick you into something silly. So we plug this into our calculator, we hit equals, and we get that this equals 7. So we have 7 in our magnitude, so we're going to then say that the unit vector equals 1 over 7, 1 divided by magnitude, times the direction. So that would be 2I plus 3J minus 6K. And we leave it in IJK format because our question is in IJK format. So we always want to match the format of our answer to the format of the original question, no matter what we work in. So part 2 tells us that for the case where angle ATP equals cos to the minus 1, 2 over 7, find the value of A. So angle from A to T to P. That's a very odd angle. But luckily, it all works in 3 dimensions quite happily. So we need to see who is ATP. ATP would be the vectors T to A and T to P. Because remember, for an angle, we want our vectors to originate. Now, cos to the minus 1 equals 2 over 7. Angle ATP equals cos to the minus 1, 2 over 7. We know that if we do the angle of ATP, we're going to get to a point where we say cos to the minus 1 of something. Now, obviously, that something is going to equal 2 over 7. So now we have a slightly unusual way where we're building this equation. So how do we do it? Well, we need to start with TA and TP. So T to A equals, and we go back and we walk. So let's just take this off so we can see P clearly. And then we should also change color. So from T to A, well, we're going down 8, so minus 8k minus 6j. So TA equals minus 8k minus 6j. But remember, we leave it in ijk so we don't get confused later. Minus 6j minus 8k. Now we'll go and make this a rainbow answer. Let's go do TP. So from T to P, we can go in all sorts of different directions. I mean, you're going to end up with the same answer. But I'm going to go, I've got a short little 2k to go up here. Then a minus 6j. Then there he is, minus AI. So we've got that A now. So we're going to have that unknown. We're going to have to work with it until such a time as we can sort it out. So TP equals, we said 2k minus 6j minus AI. And again, we put it into ijk. So minus AI minus 6j plus 2k. So now we have our two vectors ready to go. So let's go back to our blue to make things a little bit easier. Now, I'm not a person who is fond of ijk, so I'm going to put them into columns to work. So I'm just going to put it here. So it's nice and handy. ijk, so 0, minus 6, minus 8. And TP is minus A, minus 6, 2. So now I've got my vectors in columns. I'm much happier to do the question. In order to do an angle between two vectors, we need a dot product and we need two magnitudes. So starting with a dot product, TA dot TP is going to equal, multiply, then add. So 0 times minus A plus minus 6 times minus 6 plus minus 8 times 2. So of course that one's going to disappear. We have 36 minus 16, which gives us 20. Magnitudes. So the magnitude of TA is going to equal square root. 0 squared is 0, minus 6 squared plus minus 8 squared. And the square root of all of this jazz is, quite wonderfully, 10. Then we have TP. TP is the square root of minus A squared plus minus 6 squared plus 2 squared. So now we have the square root of A squared plus 40. Because remember, minus A times minus A is plus A squared. We can't do anything with that. We can't take a square root because we have two little terms sitting under that root. So he has to stay on the outside. We must leave him there. So now we know about all the elements that we need to do cos ATP. Cos ATP, all the biologists are sitting giggling. Okay, cos of ATP is dot product over moduli. So 10 square root A squared plus 40, no lazy square root lines, no lazy fraction lines. So then we know that ATP equals cos to the minus 1 of 20 over 10 root A squared plus 40. And now we have something that looks rather like our question. Cos of all of that must, cos to the minus 1 of all of that must equal cos to the minus 1 of 2 over 7. So therefore, 2 over 7 equals 20 over 10 square root A squared when the pen wants to behave, plus 40. Let's get rid of those fractions. So 7 times 20 gives us 140 equals 20 square root a squared plus 40. Getting rid of that 20, we would then have a squared plus 40 equals, beautifully simply, 140 divided by 20 gives us 7. So now we know that a squared plus 40 equals 7 squared, 49, because we're going to square both sides. So a squared equals 9. And a equals 3 or minus 3. So if we look back, find the value of a. A is a constant. We're working with vectors. Our a here is a plus 3. So we just have the one solution for a equals 3. But you never, ever, ever break that habit of checking whenever you take a square root. Are we happy? Okay, so looking good. Let us move on to the next question. Relative to the origin O, position vectors of points A and B are given by OA equals and OB equals. Find the cosine of angle AOB. So this time we're taking that angle all the way through. Same thing at the beginning. OA, whoa, not OAB, nonsense. AOB. So there's our vectors, OA and OB. Wonderful, we've got them. So, same thing, dot product. OA dot OB equals 3 by 6 plus 0 by minus 3 plus minus 4 by 2. So, that gives us then, that's going to disappear. We combine those two and we get 10. Exactly the same thing as before, magnitude. OA equals square root 3 squared plus minus 4 squared, being careful of our signs, going to equal 5. Magnitude OB equals square root 6 squared plus minus 3 squared plus 2 squared. Magnitude of OB is going to give us 7. So, very nice and straightforward. We now know that cos AOB equals dot over moduli. So cos AOB equals 10 over 35, and you put the brakes on. Because we're not going to do an inverse cos, we're just going to simplify this fraction. 10 over 35 is the same as 2 over 7, and they only asked us for the cosine of angle AOB. They didn't ask us for angle AOB. So if you then went and you actually did a cos to the minus 1, you've got a problem and you've lost marks because you didn't answer the question. Question asked for cosine of angle AOB, so we stop at cos AOB equals 2 over 7. So what's waiting for us in part 2 of this question? The position vector of C is given by OC equals K minus 2K, 2K minus 3. Goodness gracious, okay. Given that AB and OC have the same length, find the possible values of K. Okay, length we're dealing in, magnitude again, same formula. But here we have an AB. We have a displacement vector. So before we can do anything with this OC, we need to get that AB. So remember that AB equals B minus A. So 6 minus 3, 2 minus 3, 0 minus 4. So where's the second one? Minus the first one. So 6 minus 3, 2 minus 3, 0 minus 4. And that gives us 6 minus 3 is 3. Minus 3 minus 0, lovely, minus 3. 2 minus 4 is 2 plus 4 is 6. So now we have our AB. Now we know same length. So magnitude of AB equals magnitude of OC. And at this stage, I'm not going to bother with square roots, because if I'm going to have square root equals square root, then it's not going to work out as anything other than just squaring both of them. So in this case, we're going to have square roots skipping. So magnitude of AB, we can just go straight to 3 squared plus minus 3 squared plus 6 squared. I do want to show that. Okay, equals OC squared, we would have K squared plus minus 2K squared plus 2K minus 3 squared. And you can see they are testing a whole lot of exponent laws here. So when it comes to this sort of thing in stating formulas, we generally don't tend to state formulas. When you are doing an angle question, sometimes it can be nice to say the formula if you're keeping track and when you're practicing them. As you get towards preparing for your exam, there is no need to write down the formula because you are going to use it. And the key thing is a substitution into that formula. So in this case, we just say that we're using the magnitude and we can go straight into the squaring of each component. So 3 squared plus minus 3 squared plus 6 squared gives us 54. Then we get a k squared plus a 4k squared plus a 2k, 4k squared minus 6, so minus 12k plus 9. Again, if you're struggling with expanding brackets, rather write them out, show the 2, do your FOIL. But you should be getting to a point where you can do these in your head. Obviously, we have a quadratic, okay, and we're looking for possible values of k, so things are falling into place. So let's get it all together. So 0 equals 159k squared minus 12k plus 9 minus 54 minus 45. Big numbers. So what can we simplify? I reckon we can get rid of 3 out of each of those. So 0 equals 3k squared minus 4k minus 15. Yes, we are going to factorize. So 0 equals, this first 3 is prime, so it has to be a 3k, a k. So making a 4 through a subtraction, 1 and 15 ain't going to work. 3 and 5 looks a little bit closer. We could have a 3 here, 3 and 3 is 9, because that gives us a 5 there, 9 minus 5 gives us 4. So we want a minus 4k, so we want the big one negative, so we will be minus the 9 plus the 5. So from there we then know that k equals minus 5 over 3, or k equals 3. 2 possible values of k based on that relationship of the same length. So it's really important that you are happy with your formula for magnitude, happy with your formula for angles, dot products. What else? Let's see what we get. Relative to an origin O, the position vectors of A, B, and C are given by A is cool, B is cool, C has some funny stuff going on. In the case where A, B, C is a straight line, find the values of P and Q. Okay, so we got a straight line going through A, B, and C. Well, that means that the direction AB, BC, AC, it's all the same direction. So we would know then that we would have a relationship that AB equals K times BC. We don't need a bracket there. Okay, because even if they're same length, if B is in the halfway point, then K would be 1. But the thing is that we know that this direction, this basic, is going to be the same. So we're working effectively with parallel vectors. Brilliant stuff. So in order to do this, we need an AB, we need a BC. So let us start with that. So AB is going to be B minus A. So 2, 5 minus 2 minus 0, 2 minus 3, which gives us a 2, 3, 1. Then we need a BC, because we've got to have that unknown in there as well. BC is going to be 3PQ minus 2, 5 minus 2. So that would be the 3 minus the 2 gives us 1, P minus 5, Q plus 2. So we've got our vectors that we're going to work with. Now we put them into our relationship. So therefore, we have then that 2, 3, 1 equals K times 1 P minus 5 Q plus 2. And it's a wonderful thing when you look at something like this and you say, ah, look, I've got my X components. So for value of K, we know that 2 equals K times 1. So K equals 2. Then we can do for value of P. So now we use our Y components. So 3 equals, and now 2 times P minus 5. So we would have then 2P equals minus 10. 2 times, what am I saying? 2 times minus 5 is minus 10. There's our 3. So 13 equals 2P, and P equals 6.5. Decimals can be neater when it comes to vectors. Fractions are a little bit clumsy. Okay, so let's rather go for 6.5 for P. Then for value of Q, we would use our Z component. So 1 equals K times Q plus 2. But K, of course, we have a value for, I think it's getting time for T. K, we said, is 2. So 1 equals 2Q plus 4. So then we would have, this would be a minus 3 equals 2Q, and a Q equals minus 1.5. And there, this would be good. That's more visible. So through all of that, we got that K equals 2. We have that relationship between vectors of the same direction, effectively parallel vectors. And then we use our Y component to solve for P is 6.5, and our Z component to solve for Q is minus 1.5. So then we have another question that says, in the case where angle BAC is 90 degrees, express Q in terms of P. And our last one, where P equals 3 and the lengths of AB and AC are equal, find the possible values of Q. So I'm not sure we're going to get all the way to this one, but we have done an equal lengths one. So let us talk about this one, because this one is our special one. 90 degrees, perpendicular. So we would need then for our angle, BAC. So AB and AC. AB, we already have. Wonderful stuff. AB equals 2, 3, 1. AC is going to equal C minus A. So 3PQ minus 0, 2 minus 3. So this would give us 3P minus 2, Q plus 3. Okay, when angle is 90 degrees, the vectors are perpendicular. The dot product equals 0. So we then know that 0 equals 2 by 3 plus 3 by p minus 2 plus 1 by q plus 3. Two unknowns, but they want to express q in terms of p. So we get q equals. So getting rid of all these brackets, 0 equals 6 plus 3p minus 6 plus q plus 3. So q equals 6 minus 6 plus 3, move them over, so minus 3. And then 3p would become minus 3p. And then just for neatness, because they do want q as a subject, q in terms of p, I would then have a final solution. Q equals minus 3 minus 3p. So perpendicular vectors, a very, very handy tool when you're looking at a dot product equals 0, because we don't need to work with cos, we don't need to work with magnitude, we can just focus on that dot product. So whenever you see it, take that opportunity with both hands. So if you want to work through part 3, your final answers for this one will be that q equals minus 1 and q equals minus 5. So obviously when your lengths are equal, it's all about magnitude being the same. And you've got a value for p, so you have one unknown q. So you are developing them, being very careful of your squaring rules and working through that solution using the techniques that we've used already in this lesson.